Hello everyone, my name is Katharina.lingelbach and I'm a PhD student at the University of Oldenburg and at the Fraunhofer Institute for Industrial Engineering in the field of applied neurocognitive psychology. I'm happy to present you today our research on the interaction of emotional and cognitive processes, and more precisely, on the effects of emotional distractors on working memory load. In the past, theoretical models that try to explain the relationship between emotional and cognitive processes assumed a rather modular architecture with cold cognitive and hot affective emotional systems. However, nowadays, these models have been progressively revised. Today, we assume that both mechanisms are closely interwoven and even processed in shared networks. It is important to research the relationship of cognitive and emotional processes because particularly in naturalistic environments, so in our world today, we are confronted with complex and socio-emotional stimuli triggering both processes at the same time. You can look from two perspectives on the interaction. First, by investigating effects of cognitive processes on emotional processing. This would, for instance, include effects of reappraisal, or second, by investigating effects of emotional processes on cognitive processing. And this is what I'm focusing today and in my research in general. Let's have a look of typical emotional distractors in our everyday life during cognitive tasks. This can be an argument during driving, acute distraction in the environment, or laughter and cheering, like in the image above with the child singing, or below when driving to a party with friends. Previous research investigating the interaction between emotional and cognitive processes observed detrimental effects of emotional distractors on cognitive processes. The strongest emotional interference was observed first under low working memory load, so when the cognitive load was low because of sufficient available resources to process the emotional stimuli fully. And second, when the distractors' variance deviated from neutral, so when they were either positive or negative because of a higher salience and relevance. But how can we investigate these effects and also the correlates? One possibility is by using electroencephalography. And previous research and the literature suggests the frontal alpha asymmetry to be a suitable correlate to investigate emotional states. And for cognitive states, the ratio between frontal theta and parietal alpha power is suggested to be suitable. When looking at the frontal alpha asymmetry, increased right frontal alpha activity index a negative emotion and withdrawal, whereby an increased left frontal activity is associated with positive emotions and an approach. For the cognitive state index of higher values of the ratio is associated with a higher cognitive load. We were interested in the following three research questions. First, how auditory distractors and their effective valence influence neurophysiological indices associated with valence and working memory load. Second, whether the suggested correlates of the frontal alpha asymmetry and cognitive load index are suitable to capture the interaction between cognitive control and effective emotional distraction. And third, whether we observe stronger emotional interference effects under low working memory load because of the sufficient resources to process the emotional distractors, and second, for emotional stimuli due to a higher salience. To investigate these research questions, we recorded EEG data from 12 participants with a mobile EEG device with dry electrodes. The used EEG device you can see on the images above. Let's have a look at the experimental procedure we used in our study. As a task, participants had to perform either easy arithmetic additions with one-digit numbers in the low working memory load condition or harder calculations with two-digit numbers in the high working memory load condition. We induced emotional states via simultaneously presented auditory files of the EIDS database. So let's have a look at one trial. First, we presented a fixation cross, followed by the first number, which needed to be remembered. Then we had an interstimulus interval, followed by the first number, which needed to be added to the first one. So this is the first stimuli, and at the same time, participants had to listen to a file of the EIDS, here in this trial with negative valence. Afterwards, we let participants rate their feelings on the emoji grid scale. So this scale has got an axis for valence and also arousal. So one answer for both dimensions at the same time. Then we had a further interstimulus interval and a further number to be added. Again, a rating. And then we prompted participants to enter the result of their calculation. And of course, we provided feedback whether the answer was correct or wrong. At the end, participants had to rate how much effort they perceived during the trial on the NASA task load scale. So for the analysis, we looked at the intervals during the calculation when the number was presented in addition with the auditory file. So this was the epoch interval. To analyze the signals, we used the typical EEG processing pipeline. First, signals were detrended, zero padded, and re-referenced, followed by a filtering with first a notch filter and afterwards a bandpass filter. Then we epoched the data with 4 seconds epochs starting after stimulus onset. On the epoch data, we did an artifact removal with an amplitude rejection and independent component analysis by selecting affected components manually. Then afterwards, on the clean signal, we did a fast Fourier transformation with the Wealth method and calculated the two indices, first the workload index and then the frontal alpha asymmetry index. And on these indices, we did some statistical comparisons by using bootstrapped confidence intervals and grand averages. So let's have a look at the results. First, of the frontal alpha asymmetry index. You can see on the left side a figure showing the grand averages calculated by bootstrapping per condition, and the dashed line indicating the threshold between positive and negative. So everything below the dashed line is perceived as rather negative and above as rather positive. On the right side, you can see a figure showing the contrast of the conditions, so the differences. And the whiskers representing the Bonferroni corrected confidence interval. So when a confidence interval is not including the zero, it is perceived as significant. Two findings of these results are that emotional processing is altered by the level of working memory load, and we observed significantly reduced frontal alpha asymmetry values and therefore less positive evaluation for positive stimuli under high working memory load compared to low working memory load. And further, we observed that the emotional evaluation was rather negative, independent of conditions, so in all conditions. When looking at the results of the working memory load index, we observed that neutral stimuli seem to have the strongest emotional interference effects during the working memory load task. So they induced further cognitive load compared to positive and negative stimuli, but this was a non-significant finding. And we observed in general no significant differences between the conditions. To summarize our findings. First, emotional processing is altered by the level of working memory load with strongest effects on positive stimuli. Neutral auditory distractors seem to induce additional workload compared to emotional stimuli, at least in our study. And third, the frontal alpha asymmetry index revealed significant differences between the conditions, but we could not observe any differences for the workload index. So additional research is necessary to investigate new approaches that not only explain the consequences of the interaction, but also the interaction process itself. And the implications of this research include high context sensitivity and holistic evaluation of identified mental states in safety critical environments, for instance, during driving or in a human-computer interaction. So this was my talk, and I thank you very much for your attention and looking forward to a nice discussion and some questions from your side.